Cryptomatte render element in V-Ray for 3ds Max. Now, we have a complex scene with hundreds of parts to it, and we need to break out all these components into very specific and complex mattes. Using regular RGB multimattes could need hundreds of matte passes that could easily take several hours to assemble. With Cryptomatte workflow, this process can be much easier. In the Render Setup window of 3ds Max, start off by making sure in the V-Ray tab's frame buffer rollout that the file output is set to an OpenEXR image. The Cryptomatte render element requires that the renders are saved as a multi-channel EXR. Next, make sure that the image sample type is set to bucket, since Cryptomattes require certain information from the renderer that the progressive sampling currently does not yet generate. You can see from the Render Elements tab that I already have 4 variations of the Cryptomatte render element configured in the scene. Now each pass is set to use a different ID type. The first one uses node name, which creates mattes based on the node names in the scene. The second one uses node name hierarchy, which creates a similar result to the first one, but any linked or grouped objects will be considered and matte colors will be assigned accordingly. The node material name option uses the materials in the scene to create the mattes. Now, since all the petals in the scene use the same material, they would all be in the same matte color. And layer name basically takes into account the different layers in the scene. In this case, we have bee and flowers in different layers, so they will have separate matte colors, and the different flowers will also be separated out from each other. Now, I'll create an additional Cryptomatte render element, and this one will use the node user property ID type. Now, when I include the name of a custom property in the node user property parameter, this pass will matte out only the items in the scene with that property setting. So let's say we want a specific selection of petals from the flowers. For the node user property parameter, I will type petal selection. Now I'll copy that to my clipboard to make this easier to add to my selection of items. I can then select just the petals I want to include in this new matte. This selection can be for any object, and it's only coincidence that I've got only petals here. Once I'm done selecting my items, I'll right-click and from the quad menu, choose Object Properties, and on the User Defined tab, I can paste the name of my user property name from the Cryptomatte pass and include an =1 to the end of it. This will give all the selected items a custom user property that is evaluated by Cryptomatte render element. Therefore, they will be given the same matte color for that pass. Now we can render all these render elements out. Taking a quick look at the results in the VFB window, we can see the node name pass with each item getting its own individual color. The additional node name passes are service elements that store information used by our pass to help generate the information that we need. They're not really used for anything after the rendering is complete. Looking at the node name hierarchy pass takes into consideration the grouping and linking of the objects in the scene. If I jump down to the material matte pass, everything that has the same material will have the same matte color. So all the petals are the same, the center of the flowers have the same color, and the different pieces of the bee are matted out by their materials. Now if we go down to layer name, everything that's on the individual layers will be colored together. So we have the bee, the center of each of the flowers, and the petals of each flower are all colored based on the layers of which they are a part. Now, looking at the pass I just set up in this demo, we can see that everything has the same matte color except for the petals that I included in my selection because of the user property. Now, let's take a look at the crypto passes in Nuke. I've already loaded up the multi-channel EXR. You can see from the channels dropdown that everything we set up in Max is available in its own pass from the single rendered file. This won't come in with the background image that was set up in the VFB, so for consistency's sake, I'll simply merge it back into the renders. Create a Cryptomatte node in the graph. Then connect it to the multi-channel EXR. This node is set to use the user properties, and we can see the results in that pass. To make a selection, choose the picker add color and hold down the control key and click. To add to the selection, just continue to click additional matte colors. We can also use the Clear button to remove picker selections. The single selection checkbox forces only one matte color selection at a time. The Matte Only option shuffles out the rest of the mattes and leaves us with just what we have selected. Now I'll connect this node to an existing grade I've made. From the settings of the grade node, I can quickly change the color of my selected petals. For the other two Cryptomatte nodes that I already had set up in my graph, the one to the right uses the Materials ID pass, and the one on the left masks out the bee. So the grade for the bee helps lighten up all the pieces of the bee quite easily. The grade for the petals adds a tint to all the flower petals in the render. And the new grade that we just made can add even more tinting to just those masked out petals. Okay, let's go ahead and take a look at this in Fusion. To the right I have our Cryptomatte pass imported in, and I want to get it useful as a mask. I'll add a new Cryptomatte node and connect it to the input. Pressing 2 on the keyboard will let you look through it. If I move the helper around and place it over one of the matted out petals, I can add it to the matte locator. Now if I move it to the bee and press add again, it adds everything else from the pass into the map because of the matte colors in the render. If I click the remove button, we go back to just having the selected petals matted out. Now if I check matte only, we get a perfect mask in the RGB channels of just the selected petals. This can easily be used for color correcting only those specified petals. Now let's add a new color corrector node. I'll plug it into the rest of the graph, then connect the Cryptomatte as a mask. Now looking through the color corrector, if I change the hue, you'll notice that only the specific petals got that new color. And that's just a few simple examples of how you can use the Cryptomatte workflow.